Section 15.3, area and volume. So for example number 1, this one is going to blow your mind. Watch. Suppose that you go up to a y value of 3. You go over to an x value of 4. And then find the area of this rectangle. You might think the answer is 12, but you need to use third semester calculus to do it. So what you do is you take this interval that goes from 0 to 4 and you divide it into a bunch of pieces. Each one is going to have a width of delta x. Then take the y-axis going from 0 to 3 and divide that into a bunch of pieces. Each one is going to have a width delta y. So then what you basically do is you have a strip that's going up like this that is a width of delta x. You have a strip going across like this, which is a width of delta y. And then where those two meet, there's this little rectangle, and the area is equal to delta x times delta y. And then if we could just have that rectangle start in this little corner right here, go across until it's filled up the bottom, and then the next one, and then the next one, and the next one, and the next one, add up all those rectangles, that's the total area. So now we're going to use third semester calculus. So integrate and find out each dx times dy. So that's basically saying add up all of these dx times dy's. So when you integrate with respect to x, you pretend that y is a constant. And x is going to change. So that would be like starting down here with y equal to like a 0.1, hold it constant, and then just fill in a rectangle straight across like this. And then do the next one and the next one, etc. So x is going from 0 to 4, and y is going from 0 to 3. And you start with this one first. So the antiderivative of dx is x, and then that gets evaluated from 0 to 4. And then there would still be integrate with respect to y from 0 to 3. And then evaluating this, that would be 4 minus 0, so that's just 4 times dy. Whoops, this is a 3. And then integrate with respect to y, so that would be 4y evaluated from 0 to 3. And then that would be 4 times 3 minus 4 times 0. And through the power of calculus, I found that the area of the rectangle is 12. All right, that was fun. Now let's try one that's a little more challenging. So for example number 2. Find the area using a double integral. And then this is the area that's being talked about. So one is this little bell-shaped curve function that looks like this. And then that function is y equals 1 over x squared plus 1. And when x is equal to 0, it's going to be 1 over 1. So this is a height of 1 right here. And then make a line that goes like this. And this line right here is going to be y equals x minus 3. So it's got a positive slope, but it's crossing the y-axis right here at negative 3. And then have x go from negative 1 to positive 1. So find this area in here. Now when you do a double integral, you can do double integral dx dy. Or you can do double integral dy dx. And they will both give you the same answer. But there are times when this one's going to be easier, and there's times when this one's going to be easier. It all depends on the region that's being talked about. So previously I had made those little lines and these little lines, and I integrated with respect to x first of all. So y is being held constant. So basically, when I do this first integral, it's saying you've got a rectangle right here at the bottom, which came from one square and another square, and it goes across like that. So that's what I'm going to do on this picture. So on this one, I need to decide, should I put that little rectangular strip vertically or should I put it horizontally? Well, the answer on this one is definitely put it vertically, because if you put it horizontally, you're going to have to end up doing 3 integrals, because you'll have to have it going across from -1 to 1. You'll also have to have it going across from -1 to this line, and then you'll have to have it going from this function to itself. And just that part is difficult when it goes from a function to itself. So instead, I'm going to make the rectangle go like this. So that means that no matter where I move this rectangle, it's always going from the top function to the bottom function. If I move it over here, it's going from the top function to the bottom function. All right. So this one is going vertically, so that means we're going to be doing y first. So it's going to be double integral. dy goes first because this is in the y direction, and then x. And then right here for the limits, we need to put what y equals. So that's nice because it's already right there what y equals and what y equals. So on the top, it's 1 over x squared plus 1. And on the bottom, it's x minus 3. And last, we need to put what x goes from and to. So from -1 to 1. And then go ahead and integrate. So the antiderivative right here is just going to be a y that gets evaluated from x minus 3 at the bottom to 1 over x squared plus 1 on the top. And then later, we'll integrate with respect to x, going from -1 to 1. And this is area. So for this part, it's just going to be the top limit minus the bottom limit. So that'll be 1 over x squared plus 1 minus x minus 3. And then later we'll integrate with respect to x. So then for the antiderivatives. So I guess you could simplify this, but it's just distributing a negative sign, so I don't really need to do that as a separate step. The antiderivative here is tangent inverse of x. And then this would be integrate x, so it's going to be minus x squared over 2. And then distribute the negative, so this is a positive 3, so that'll be positive 3x. And then evaluate that from -1 to 1. So that'll be tangent inverse of 1 minus 1 squared over 2 plus 3. And then minus tangent inverse of -1 minus a -1 gets squared over 2, and then this will become minus 3. So tangent inverse of 1, that is pi over 4. And then this would be 2.5, so plus 2.5. Tangent inverse of -1, that's actually negative pi over 4, but with that negative means it's plus pi over 4. And then this would be negative 3.5. With this makes it positive 3.5. Oops, I forgot I was using decimals, 3.5. So then adding these two together will be 6. And adding these two together will be pi over 2. Or 6 plus pi over 2, 7.571 if you go to 3 decimals. Now I think I want to check the answer. So what I'm going to do is go to this, because the calculator, at least my TI-84, can't do integrals like this, but it can do integrals like this. So then what I'll do is, first of all, pretend that I'm going to graph it. 1 divided by x squared plus 1. I need another parenthesis. And then minus x minus 3. And then zoom standard. I don't really need to see the graph. Okay, that's nice. And now calculate. Number 7 will integrate from -1 to +1. And it says the same thing. Excellent. And now for example number 3. Find the area between the first function is going to be x equals 9 minus y squared, and the line y equals negative x plus 3. So first of all, this one right here is a parabola. And because the y is squared, it's opening to the left or to the right. With this being a negative, it's opening to the left. And because of this 9, that means x is going to equal 9. And then it opens to the left. So this is the parabola. If you put x equals 0 and solve, you'll get that y equals a +3 or a -3. And this line crosses the y-axis at 3 and then goes down. So it looks about like this. And then we need to find this area in here. So now you need to write down the representative rectangle. And should it go vertically or should it go horizontally? You're right, this one should go horizontal. Because if you go vertical, you would have it going from the parabola to the line at this point, and it would go from the parabola to the parabola at this point. Which means that you would need to divide it right here and do one integral for this part and a second integral for this part. That's twice as much work. Instead, make the rectangle go horizontal. And that way, no matter where you put it, it's going to go from the line to the parabola. And because this is going the same as the x direction, that means we're integrating with respect to x first. So it's going to be double integral with respect to x first, and then y. Okay, now what are the limits? Well, with this, I need to know what x equals. So you have to put what x equals here and what x equals here. This one's already solved for x. This one I need to solve for x. So let's see, I could add x to both sides and I could subtract y from both sides. And it needs to be the bigger one, or the one on the right goes up here. And the smaller one, or the one on the left, goes down here. And then what are the limits for y? So at the very biggest, y is a 3. But then it needs to stop right here. And for that y value, I don't know what it is yet. So what I need to do is make some scratch paper over here. And this one has been solved for x, so I could take that and plug it in for that x right there. So this equation would look like y equals negative, and then substitute this for x, and then it's got a plus 3. So let's see, this would be negative negative, so that is positive y squared. And then I could subtract this y and put it on the right side, so it's set equal to 0. This would be a negative 9 and a positive 3, so that's a negative 6. And then let's see if I could factor that. So y plus something and y minus something. This would need to be a 3, and this would need to be a 2. So that's factored, and then this one will say y equals 3, which is good, that's that one. And this will be y equals negative 2. And according to my picture, that even makes sense, negative 2 right there. So the limits are negative 2 to 3. And now do the actual calculus. So integrate with respect to x, this just becomes x. Evaluated from negative y plus 3 to 9 minus y squared. And then later, we'll integrate with respect to y. So then, substituting the limits, it'll be 9 minus y squared minus negative y plus 3. And then that needs to be integrated with respect to y. So this is, let's see, negative y squared, and there is negative negative, so there's positive y, and then there's going to be 9 minus 3, so that would be a 6, and then all of that we still need to integrate with respect to y. So that's going to be negative y cubed over 3 plus y squared over 2 plus 6y being evaluated from negative 2 to positive 3. So negative 3 gets cubed over 3 plus 3 gets squared over 2 plus 6 times 3, and then minus negative of negative 2 gets cubed over 3 plus negative 2 gets squared over 2 plus 6 times a negative 2. So this would be 27 divided by 3. That's going to be negative 9. This will be 9 halves, and that's an 18. And then minus, so this is going to be negative 27 divided by 3. Well, actually negative 27, and then another negative is going to be positive. So this is going to be 27 divided by 3 is 9. And then this is going to be 4 halves, so that's just a 2. And then this is going to be a negative 12. So how much is all of that? So there is negative 9 plus 9 divided by 2 plus 18, and then this would be minus 9, minus 2, and plus 12. So the grand total is 14.5. Whatever the units are, it's squared, because we're finding area. And now that we've had a lot of fun finding area, let's find volume. So notice that when you do a double integral, and then you put dx dy, and you put the limits, and you do the integral, that finds area. And so since I don't have specific limits to put right here, I could just say that's over the region R. So for example, this last one where I had it shaded in black, the area that we found, that could be called R, that region. Then if you evaluate the double integral over the region, and then you put a function in here, times the dx times the dy, well now this would be area times another unit, so that's volume. So what you're doing is you're finding this function right here is up in space. This r is in the xy plane. So basically you're underneath this function. You're walking around this region R in the xy plane, and you're finding the volume between those two. And then let's do an example. So for example, this is number 4. Find volume between or bound by f of x and y, or in other words, z equals 4 minus x squared. And also x plus y equals 2 in octant 1. And octant 1 just means that x is positive, y is positive, and z is positive. So this right here, that's a paraboloid. So that looks like a parabolic sheet, or in other words, like a piece of paper that's been folded like this, and then it's upside down. And because of this 4, that's saying z would equal a 4 and then minus something. So that means z would start at 4, and then it would be a parabola going down like this. And if you set that equal to 0 and solve for x, it's going to be a 2. And then on the other side would be negative 2, but we're only using the positive side. So then if you create a line that's parallel to the y-axis, and then you draw another, and then another, and another, so that's the shape. Now what about this part? So x plus y equals 2. So if you set y equal to 0, that means x equals 2. So that's actually this point right here. And if you set x equal to 0, then y equals 2. So that would be right about here. And then that would be a line that's going like this. And then this down here is the region that's being talked about. So now in that region, we need to draw the representative rectangle. In this particular shape, you could have the rectangle go from the y-axis out to the line, so it could go this way, or it could go from the x-axis to the line. I'm going to have it go from the x-axis to the diagonal line. So this is my representative rectangle. And then this line is going the same direction as the y-axis, so that means we're going to do dy first. So you need to substitute in the function right there, so that's this part. 4 minus x squared. And then we're doing dy first, and then dx. Now, what does y equal? Well, for the lower limit, that's going to be right here. That is when y equals 0. And for the upper limit, that's going to be the very edge of this red rectangle right here. And if you solve for y, that means that y equals 2 minus x. So it's going to go to 2 minus x. And then what does x do? So x goes from right here when x is 0 to right here when x is 2. All right, that's the hard part. Now the easy part, integrate. Integrating with respect to y means you treat this as a constant. It will just stay there. And then the antiderivative of dy is y. And that gets evaluated from 0 to 2 minus x. And then later we'll need to integrate with respect to x. All right, so we've integrated. Now substitute the two values for y. So this 4 minus x squared just stays there as if it was a constant. And then you substitute the first value, that would be 2 minus x, and then minus when you put a 0 right here. And then we should probably do some algebra before we do the last integration. So this is really just 2 minus x times this. So I'm going to go ahead and multiply that out. So there would be 2 times 4 is 8. There would be 2 times negative x squared. There would be negative x times 4. And there would be negative x times negative x squared is positive x cubed. And then integrate that. So this is example 4 continued. So the antiderivative would be 8x minus 2x cubed over 3 minus 4x squared over 2 plus x to the 4 over 4. And then that gets evaluated from 0 to 2. So it'll be an 8 times 2 minus 2, and then 2 gets cubed over 3. Minus 4, 2 gets squared over 2, and then 2 to the 4th over 4. And when you put a 0, that's going to be 0, 0, 0, 0. Thank goodness for the 0. So then we just need to finish this. So that's going to be 16. That would be 8, makes it 16 thirds. This would be 4, that's 4 times 4, so that's negative 16 halves, or 8. And then this is going to be 16 divided by 4 is 4. So that's going to be 20 minus 8, so it's 12, minus 16 thirds. 12 minus 16 thirds, 6 2/3. So that would be the volume. So whatever the units are, it would be in cubic units. So here's a quick look at the volume that we just found. So this is the original shape, just like I showed you with my fancy piece of paper. There we go. And then graph x plus y equals 2, which actually makes this plane right here. And then we were talking about quadrant 1. So when I drew the representative rectangle, it was this, first of all, it was this little triangle down here, and then the rectangle went this way. And so then basically we're finding the volume. So you take this rectangle and then go up all the way to the red part, and then find all of that volume in there. So that's the volume that we just found. And now it's time for example number 5. Evaluate the integral, the double integral of y squared over the region R, and this means dA, or d area. So that means you can put dx or dy or dy dx, it's up to you. So it depends on what the picture looks like. So to finish this one, if R is the triangle with vertices 0, 1, 2, 5, and 3, 1. So let's see what that looks like. 0, 1 would be right here. 2, 5 would be approximately right here. And then 3, 1 would be right here. So this is the triangle that's being talked about. And then we need to know what function actually creates that line. So just use beginning algebra, subtract y2 minus y1, that would be negative 4, x2 minus x1, so the slope is negative 4. And then find out what the b is, and you'll get this. Let me just double check that I did that right. If I plug in x is a 2, this is going to be negative 8 plus 13, which is 5, so that works. And if I plug in a 3, this is going to be negative 12 plus 13, which is 1, so I did that one right. And then for these 2 points, then find the slope, so that's going to be 5 minus 1 is 4 over 2. So that would be a slope of 2, and the y value is going to have to be 1. So y is 2x plus 1. Let me see if it works. 2 times this plus 1 equals 5, yes. 2 times this plus 1 equals 1, yes. Okay, so those are the lines. And in case we need it, this line right here is just the line y equals 1. All right, now for setting up the integral. So again, get the red pen, which is right here, and make the representative rectangle either go sideways or vertical. Well, on this picture, if you do it vertical, you're going to have to do 2 integrals. One that goes from this line to the bottom, and then one that goes from this line to the bottom, and you'll have to divide it right here at x equals 2 and do 2 integrals. But if you put it horizontally, then it always goes from the line on the left to the line on the right. So let's do that. And then that means we're going to integrate with respect to x first. So don't forget the direction said integrate y squared times. And then we're going to do x first and y later. Now this means we need to know what x equals. So for each one of these, we'll need to solve for x. So I would have y minus 13 equals negative 4x, or y minus 13 divided by negative 4 is what x equals. And for this one, it's going to be y minus 1 gets divided by 2, and then that's what x equals. And for the top, it's the one on the right, so that's this one. So y minus 13 over negative 4, and this one is y minus 1 over 2. And then for the last one, so these need to be functions, and these need to be numbers. So what does y go from? So y goes from 1 at the bottom to 5 at the top. So from 1 to 5. So integrating this is going to be y cubed over 3 evaluated from 0. Oh, so I was looking at the wrong one. Y minus 1 over 2 on the bottom, and y minus 13 over negative 4 on the top. Oh, I put a 1 right there. That's supposed to go from 1 to 5. From 1 to 5. Now substitute in the limit, so it's going to be, let's see, we've already got enough fractions. I'm going to factor this one out 1/3. And then it's going to be y minus 13 over a negative 4, that's cubed. And then minus y minus 1 over 2 is cubed. And then integrate with respect to y. So now to integrate these two. There's a long way and there's a short way. The long way would be actually multiply all this out, combine the like terms. Multiply this out, combine the like terms. Then combine all of their like terms, and then finally integrate. Or you could just go ahead and integrate. So this is going to become whatever this is to the 4th over 4. And then you have to do the chain rule. So this is going to be a 1/3 got factored out. And then there would be this thing to the 4th over 4. So y minus 13 divided by a negative 4. And then the chain rule. So when you take the derivative of the inside, that part would be 0, but that would be 1. So that means it would give you a 1 over negative 4. So then you have to divide by 1 over negative 4, or in other words, multiply by negative 4. And then for this one, likewise, it's going to become add 1 to the exponent and divide by that. And for now, the inside part will stay the same. And when you do the chain rule, the derivative of this would be 1 over 2. So divide by 1 over 2, or in other words, multiply by 2. And in that, it gets evaluated from 1 to 5. All right, so the 1/3 is still factored out. And then substitute a 5. So this is going to be 5 minus 13, so that's negative 8. Negative 8 divided by negative 4 is a 2. So there's going to be 2 to the 4th. And then these 4s are going to cancel out, but they will leave the negative behind. So let me just make sure I did that right. Put a 5 in there, so 5 minus 13, that's negative 8. Negative 8 divided by negative 4 is a 2. Then 2 gets raised to the 4th. And then this will leave behind a negative. And now for this part, when you substitute a 5, this is going to be 5 minus 1, so that's 4. Gets cut in half is 2, so there's a 2 to the 4th. And then this is going to reduce to just say divide by 2. And it's still subtract. Then minus, oh, I don't think I'm going to have room right there. Well, I'll just make it fit. So then, let's see, substitute a 1. So this would be negative 12. Negative 12 divided by negative 4, that's negative 3. So that's going to be, well, it's to the 4th, so I don't actually have to put the negative. So it'll be 3 to the 4th. And then because of these canceling, it leaves behind a negative. So this is supposed to be a negative 3 to the 4th. And then when you put a 1 right there, that's going to be 1 minus 1 is 0. Oh, so I've made it fit. Excellent, because that's just a 0. Okay, so how much is all of this? So this is going to be 1/3 times, this is going to be negative 16. this is going to be 16 cut in half, so that means minus an 8. And then that's a negative, and that's a negative, so actually add 3 to the 4th is 81. So then how much is 1/3 of a negative 16 minus an 8 plus an 81? Wow, after all that, turns out that it's just the number 19. So there's the volume. Okay, for number 6, we're just going to set up the integral. So set up the integral for the volume between y squared plus z squared is equal to 4, and the plane y equals negative 1/2 x plus 2 in octant 1. So that means use x is positive, y is positive, z is positive. So this is the function that we're actually going to be integrating. The only problem is it hasn't been solved for z. So the first thing is solve for z. First, subtract y squared from both sides, and then take the square root. Usually you have to put plus and minus, but because of this, we only need the positive square root. And then we should see what region this is talking about. So I could graph that in 3 dimensions. This is the x-axis, the y-axis, the z-axis. And let's see, when x is a 0, so in other words on the y-axis, if you plug in a 0, it's going to be y equals 2. And if you plug in that y equals 0, then move the 2 to the other side, it becomes negative 2. And when you multiply both sides by negative 2, it's going to be a positive 4. So we're talking about the plane is going like this when it hits the xy plane, and then it's going straight up from there. So then I'm going to make the representative rectangle go like this. And then that's going in the y direction, so that means we're going to be integrating with respect to y. So the function is the square root of 4 minus y squared, and then integrate with respect to y, and then then x later. And then y is going from right here, y is 0, to right here, y is equal to negative 1/2 x plus 2. So that's going to be the upper limit of integration. And then x is going to go from 0 to 4. So remember, in here, these are going to be functions, and these are going to be numbers. And then that will give you the volume. And since it said set up the integral only, then we're finished.